Welcome to the Explainer. Today, we're going to pull back the curtain on something you use every single second you're online, the invisible, high-speed negotiations that make your entire digital life possible.
So here's what we're going to do. We'll kick things off with a simple analogy to frame the problem. Then we'll look at the rules and the tech that solve it. After that, we'll see how we fix errors when they still manage to pop up. And finally, we'll tie it all together. All right, let's get into it.
Okay, so to really get how the internet works under the hood, we have to start with a problem that's actually pretty familiar to all of us. I want you to imagine something. Think of a network as just one big shared room. And in that room, every single one of your devices, your phone, your laptop, your smart TV, you name it, is trying to talk at the exact same time. You can see how that would be a recipe for total disaster, right? You know, in the world of networking, this is called a broadcast channel. The idea is simple. One device transmits, and every other device on that part of the network gets a copy. And this right here brings us to the absolute core of the problem. What happens when two people at the party try to talk at once? You get what's called a data collision. Think about it. When two people at that party talk over each other, what happens? You can't understand a word either of them is saying. It just turns into noise. Well, the exact same thing happens with data. The signals literally crash into each other on the wire, and all that important information just becomes a completely useless, garbled mess. So the big question is, how on earth do we manage all this chaos?
All right, so the first solution, it's actually not about throwing a bunch of fancy hardware at the problem. Nope, it's about something much simpler, establishing some basic rules of etiquette for our little digital cocktail party. Yeah, that's a mouthful, I know. It stands for Carrier Sense Multiple Access with Collision Detection. It sounds super complicated, but trust me, it's really just a clever set of steps that devices follow so they don't, talk all over each other.
And what's so cool about this is how much it's like a polite human conversation. So first, a device listens to the line to see if anyone else is talking. If it's quiet, great, it starts sending its data. But if it detects a collision, if someone else starts talking at the same time, it immediately stops. It sends out a quick jam signal, which is basically like shouting, "Hey, everyone, stop talking." Then, and this is a key part, it waits a random amount of time before it tries to talk again. That randomness is the secret sauce here. It makes it super unlikely that the same two devices will try to speak again at the exact same microsecond. So these rules were a great start for managing the conversation. But the thing is, the actual physical hardware connecting all these devices, well, it could be made a lot smarter.
Now, to get why the hardware evolved, you really have to understand this one key concept, the collision domain. A collision domain is basically the size of our cocktail party room. It's the area where everyone can hear everyone else talk. And the number one goal of modern networking, really, is to make these rooms, these collision domains, as tiny as humanly possible. Okay, so back in the day, early networks used these things called hubs. You can think of a hub like a guy with a megaphone at the party. Any message he gets, he just blasts it out to everyone, creating one giant, incredibly noisy collision domain. Not very efficient. But then came switches. And switches are completely different. They're more like a smart telephone operator. A switch actually learns which device is plugged into which port. So when data comes in for, say, your laptop, it creates a direct, private line just between the sender and your laptop. This is a game changer because it means every single port becomes its own tiny, isolated collision domain. The result? Way less traffic, and collisions are almost completely eliminated. All right, so we've got smart switches now, and they've basically gotten rid of collisions. Awesome. But what happens if a message still gets messed up on its way from point A to point B? I mean, it could be anything. A little bit of electrical interference, a hiccup in the hardware. What then?
Because yes, sometimes, despite all our best efforts, a tiny bit of data just gets flipped from a 1 to a 0 and the message gets garbled. And this is where the network's final, and maybe its most clever, safety net comes into play. So instead of the receiver having to go, I didn't get that, can you send it again? There's a technique called forward error correction, or FEC, and it lets the receiver fix mistakes right then and there, on the spot. Just think about a video call, right? You absolutely can't afford the delay of asking for a piece of the video to be sent again. That's exactly what causes that awful lag and stuttering. FEC is the magic that makes that smooth, real-time experience possible, because it fixes errors instantly.
So how does it work? Well, here's a simple way to think about it. The sender doesn't just send your data. It also sends an extra special chunk of data that's been cleverly calculated from the original chunks. Now, let's say one of the original pieces gets lost along the way.
No problem. The receiver can use the pieces it did get, along with that special extra piece, to mathematically rebuild the one that went missing. It's like having just enough clues to solve a puzzle, even with a missing piece. It's proactive error fixing, and for the modern internet, it is absolutely essential.
So, after all this, why should you care? What does it all mean for you?
Well, it means that every single time you stream a movie, every time you join a video call, heck, every time you just load a simple web page, what you're really witnessing is the result of this perfectly choreographed, totally invisible digital dance. It's this constant, mind-bogglingly fast negotiation between polite rules, smart hardware, and instant repair kits, all working together perfectly to get data from a server halfway across the world right to your screen, right now.
And it's a system that works brilliantly for the internet we have today. But that leaves us with a really fascinating and frankly critical question for the future. As we connect billions, and I mean billions more devices to this network, from our cars to our coffee makers, are the invisible rules that prevent chaos today going to be enough for the internet of tomorrow?